Assalamualaikum and hi guys. So today we will continue for the third property, inverse Laplace of rational function. So you can refer to the textbook page 144. Inverse Laplace of rational function is applicable whereby you have a multiplication terms at the denominator. For example, you have something multiply something at the denominator here. This one also you have something multiply something at the denominator. So if we have something multiply something at the bottom side, so you have to solve by using rational function. In order to solve inverse Laplace transform by using rational function, you must know the rules of the partial fraction. So this is the notes for the rules of the partial fraction. So this example will guide you how to write in terms of the partial fraction if we have a linear factor, a repeated linear factor, and quadratic terms. For the linear factor, what is meant by the linear factor? You have to refer to the bottom side here. Linear factor means that if you have s with the power of 1. So our partial fraction now in terms of variable s, because we want to solve inverse Laplace transform. So for this example, you have 2s plus 4 divided with s plus 1 multiply with the s minus 3. Okay, so s plus 1 is a linear factor, s minus 3 is also a linear factor. Therefore, our partial fraction will be written as a over s plus 1 for the first bracket plus b over s minus 3, whereby this one is the second bracket. So this is how you have to write your partial fraction if your bottom side or your denominator in terms of a linear factor. If you have a repeated linear factor because at the denominator here, as you can see, we have s plus 1 multiply s minus 3 with the power of 2. So this is what we mean by the repeated linear factor. It is repeat by 2 times, and this one is a linear because s power of 1. So how you have to write your partial fraction if you have a repeated linear factor? 2s plus 4 divided with s plus 1 multiply s minus 3 the power of 2 will become a over s plus 1 for the first bracket plus b over s minus 3 with the power of 1 plus c over s minus 3 with the power of 2. Okay, so since s minus 3 here repeat 2 times, so that's why we have here power 1 and power 2. So let's take a look for another example. We have 2s plus 4 divided with s power 1 multiply s plus 1 with the power of 2. So this one is repeated linear term. Multiply s minus 3 with the power of 2. Also this one is a repeated linear term. Okay, so our partial fraction will become a over s, because s with the power of 1, plus b over s plus 1, s plus 1 with the power of 1, plus c over s plus 1 with the power of 2, because s plus 1 here repeat 2 times, plus d over s minus 3 with the power of 1, plus e divided with s minus 3 with the power of 2. So this one because it repeat 2 times. So how to write your partial fraction if you have a quadratic terms at the denominator? Quadratic terms means that you have a as the power of 2 plus b as plus c. Okay, so you have to always check whether the denominator can be factorized or not. For example, 2s plus 4 divided with s plus 1, which is this one is a linear term, multiply with the s square plus 4s plus 5. So this is a quadratic terms. Okay, so when we check with the calculator, this quadratic term cannot be factorized. So how to write our partial fraction? So our partial fraction will become a over s plus 1 plus bs plus c divide with the quadratic terms that we cannot factorize. So this one, if you have a quadratic term that you cannot factorize, the partial fraction will become bs plus c. For next example, we have 2s plus 4 divide with s plus 1 is a linear term, multiply with the s square plus 2s minus 3, which is this one is quadratic term that can be factorized. So when we use calculator, we will have the answer s minus 1 multiply with the s plus 3. So this answer you have to substitute back to the position of the quadratic terms. So our original terms will be changed into 2s plus 4 divide with s plus 1 is a linear term, s minus 1 is a linear term, s plus 3 is also a linear term. So now everything become linear term. So our partial fraction will become a over s plus 1, b over s minus 1, plus c over s plus 3. Okay, so this is how you have to write your partial fraction if you have a linear term. So now let us try to solve this example by using inverse Laplace transform of rational functions. Solve the following expression. So example A here, 1 over s plus 1 multiply with the s minus 2. So if you have something multiply something at the denominator, so you have to solve by using inverse Laplace transform of rational function. So the first step, you have to write in terms of partial fraction. So in order to write in terms of the partial fraction, so you have to know whether the denominator in terms of linear term, repeated linear term or quadratic terms. So this one, s plus 1 is a linear term. S minus 2 is also a linear term. So both of the denominator is a linear term. So write in terms of partial fraction. Therefore, 1 over s plus 1 s minus 2 is equal to s plus 1 at the bottom side will become a over s plus 1 plus s minus 2 at the denominator will become b over s minus 2. So after you have write in terms of the partial fraction, so now you have to find what is the value for the constant a and b. So in order to find the value for the constant a and b, you have to eliminate all the denominator here. So how to eliminate all the denominator? So you have to cross multiply. So always remember, whereby we want to eliminate all the denominator, on the left hand side, we always write everything that you have at the upper side. So left hand side will become 1 equal to, so for the right hand side, we have a over s plus 1 plus b over s minus 2. So we want to eliminate the denominator here. So if we have only 2 terms here, it's easy for us to only cross multiply. But if you have 3 terms whereby you have a, b and c, so the cross multiply is not suitable. So the simple way is a is over s plus 1. So we want to eliminate the s plus 1, means that we close the s plus 1 on the left hand side. So the things that is still open, you have to multiply with the a. So a is multiply with the s minus 2 plus b. b is divide with the s minus 2. On the left hand side, we close the s minus 2. So the things that still open here, you have to multiply with b. So b multiply with the s plus 1. Another concept is we can only cross multiply. So now you have to calculate the value for a and b. So in order to calculate the value of a and b, there are 2 methods. The first method is let any suitable value of s so that it become 0. So let any suitable value of s so that it will become 0. So means that you have one bracket here s minus 2 and another bracket at the behind here s plus 1. So what is the suitable value of s? When we substitute to the first bracket, this one will become 0. So this one s is equal to 2. For the second bracket here, s plus 1, what is the suitable value of s? When we substitute to that position, it will become 0. So s is equal to negative 1. So we have declared two value of s now. So the first s, let s is equal to 2. So substitute s equal to 2 for the whole thing here. So start from the left hand side, 1, there is no s that you have to be substitute. So we only have write 1 is equal to a multiply s minus 2, a multiply 2 minus 2, plus b multiply s plus 1, b multiply 2 plus 1. So now you have to simplify. 2 minus 2 will become 0. 2 plus 1 will become 3. So 1 is equal to b multiply with 3. So therefore b is equal to 1 over 3. So this is the value of b. So next, substitute another value of s. Let s is equal to negative 1. So substitute for the left hand side. We have 1. There is no s that you have to substitute. So 1 is equal to a multiply s minus 2. So a multiply with the negative 1 minus 2. Plus b multiply with s plus 1. So negative 1 plus with 1. So now simplify the whole thing. Negative 1 minus 2 will become negative 3. 1 is equal to a multiply negative 3 plus b multiply negative 1 plus 1 will become 0. So 1 is equal to negative 3a. So therefore a is equal to negative 1 over 3. So once you have obtained the constant for a and b, so you have to substitute back the constant into the position of the partial fraction. Substitute back value a and b into the partial fraction. So this is our partial fraction before this. So you have to substitute the value of a to the position of a and the value of b to the position of b. So therefore 1 over s plus 1, s minus 2 is equal to a will become negative 1 over 3, negative 1 over 3, s plus 1 plus b will become 1 over 3. 1 over 3 s minus 2. So after you have substitute the value of a and b, so now you have to apply inverse Laplace transform. Now apply inverse Laplace transform, which is you have to write Laplace inverse curly bracket for the whole thing. So Laplace inverse, Laplace inverse, and Laplace inverse. So from here, you have to apply linearity of first shift property for the inverse Laplace transform. So we want to solve the right hand side. So if you can see here, Laplace inverse negative 1 over 3, we have a constant at the upper side. So we bring the constant to the outside. negative 1 over 3 Laplace inverse 1 over s plus 1. The second curly bracket, we also have constant 1 over 3. So bring the constant to the outside. Plus 1 over 3 Laplace inverse 1 over s minus 2. So now, solve the inverse Laplace transform. So now by refer to the table, Laplace inverse 1 over s plus 1, whereby we have a constant at the upper side and we have s the power of 1 at the bottom side. So the suitable one is the 1 over s minus a, whereby the answer will become exponent of at. So from table s minus a, you have to determine what is the value of a. So 1 over s plus 1, our a is equal to negative 1. So from here, s minus 2, our a is equal to 2. So now write the answer based on the table of the Laplace transform. Laplace inverse 1 over s plus 1, whereby our a is equal to negative 1. The answer will become exponent negative t. So therefore, negative 1 over 3 exponent negative t plus 1 over 3 Laplace inverse 1 over s minus 2, whereby our a is equal to 2. The answer will become exponent 2t. So this is the final answer for the inverse Laplace transform by using rational function.